Okay, problem number 1. What do we have given to us? In problem number 1, what have they given to us? Well, they've given us 2 points. When we say f of 2 is 4, that's what that means, 2 comma 4. So they've given 2 points. And what have they asked us to do with those 2 points? Write an equation of a, well, stop right there. Linear function sounds hard. What do they really mean? A line. We want the equation of a line. So what do we need to do first? Find the slope. And how do we find slope? Negative 6 minus 4 over 4 minus 2. Now I think by this stage of the game, we should all be able to calculate slope correctly. Slope is y minus y over x minus x. So that's negative 5.
Can you explain why the numbers in parentheses are y?
No, these are x's.
Why?
Because when you write a function, it's f of x.
Okay.
So whatever's in there is the x. Now, what do I do now that I know my slope is negative 5? Go right back to here, pick one of my points, and in we go. So 4 equals negative 5 times 2 plus b. So 4 equals negative 10 plus b, and b equals 14. So y equals negative 5x plus 14 is our answer. Right? All right, anything else on the quiz we need to look at? Okay, then let's look at life science homework, and let's pick a problem out of that. Didn't have to do very many. So who had a question about one of the homework problems? Tomorrow we're going to have a quiz where you're going to have to write the equation of the parabola. So if you don't ask, I'm just going to pick one. All right, let's look at 39. Okay, what did they give me in 39? Did they give me a vertex? What is it? I'm going to stop right there for a minute. Because I know that the equation of my parabola is going to look like this. If all those blanks and letters bother you, you know the equation of a parabola looks like this. Where would the vertex of this parabola be? This is a made-up parabola, but where would its vertex be?
3 and 5.
3 comma 5. Right 3 up 5. So you should be able to fill in these 2 blanks using this vertex. So what would be here? If it's a minus 1, if we went left 1, this would have to be x plus 1, and this would have to be a minus 3 on the end. That tells me that my vertex is at -1, -3. Now, what do I not know from that information? What that up, down, skinny, fat number is, right? I don't know what this number is. So luckily, they gave me another piece of information. They said in the picture that the curve contains, it's not the vertex, the curve contains the point 1, 5. Now, what does that mean? That means that if I put in 1 for x, I should get 5 out for y, right? If I put a 1 in for x, I get a 5 for y. Can I solve that? You sure can. Parentheses first. So inside the parentheses we have, John Boswell, what's on there? 1 plus 1 is squared. Now don't subtract 4 minus 3 because this is 4a. You can't do that. What are we going to do here? Add 3 and divide. Lo and behold, that is a 2. So there's our answer. Okay, we need to get our brains back in gear. Did everybody follow those steps there?
So you only choose one of the, because on the graph you have 1, 5, and -1, -3.
Yeah, but we used -1, -3 already.
No, but I'm saying you solve for 1 and 5 too.
Well, we used -1, -3 in step 1 to put in where the vertex goes.
Yeah.
So then we were down to this. Then we put in, once we got our vertex put in, then we put in our other point to figure out what this number was. It's a 2-step process. First you put your vertex in, and then you put your other point in to figure out what that other number is.
So you use the same, like, vertex that you started out with? You just put in the
First you put in your vertex.
okay.
Then you put in your other point for the x and the y to solve for a. Okay, let's do one more. What was another one that I assigned? 41. All right, let's do 41. Now, the very first thing you have to be able to do, kids, is remember the setup. You gotta remember the setup of a parabola. Okay, so you gotta remember that. Then, my vertex is at 111. From the picture, it says the vertex is 111. So what's gonna go here? 1, and what's going to go here? 11. This would tell me that I go right 1 and up 11. And is that what I want to do?
Yeah.
All that's left is that missing number. So it contains the point for -7. So what am I going to do? If y is -7, then x is 4. So what's this?
Three.
3 squared is, so I got 9a plus 11. All right, so let's subtract 11. And this time I got -2. So there's your final answer.
In the parentheses, how do you know the other number? Like not x, but
This comes straight from the vertex. It said the vertex was 111.
okay.
So x minus 1 plus 11. That comes from, these are your vertex numbers.
Is it always gonna end up being 2? Oh. But you can tell if it's negative or positive by the way that.
Yeah. So we knew this was going to be negative. We had no idea it was going to be 2 again. But. All right, get your note sheets out. Okay, we're on page 16. Section 2.2. And today we're going to talk about variation. So problem number A and B are our guidelines. The formula for, well, let me ask you, do you remember what the formula for y varies directly as x is? Y equals kx. That is your direct variation. When someone says y varies directly as x, that's the setup. K is some number. Y varies directly as x. B, y varies inversely as x. So this has to be memorized. Y varies directly as x. Y varies inversely as x. Now let me give you an example so you kind of understand the difference between direct variation and inverse variation. Okay? Harry and I go to the store. We're both going to buy some bananas. Okay? Harry buys 3 pounds of bananas. I buy 5 pounds of bananas. Who will pay more? Harry's buying 3 pounds. I am buying 5 pounds. Who will pay more? Me. Why? I bought more. Direct variation. More bananas, more money. The more you buy, the more you pay. Inverse variation. Zach and I live in the same house. Not really, but for purposes of this problem. Zach and I live in the same house. We are both going to get in our cars and drive to Cathedral High School. We're going to follow the same path. Zach drives 50 miles an hour. I drive 30 miles an hour. Who takes longer to get to school? Zach drives 50. I drive 30. Who takes longer to get to school? I do. Inverse variation. Less speed, more time. So one variable's going down and the other one is going up. That's inverse. So if speed goes down, time goes up. With the bananas, both variables go the same way. More bananas, more money. That's direct. Inverse, think of chemistry class. More pressure, less volume. Right? If you squeeze that gas, less pressure, or more pressure, less volume. Inverse variation. So one variable goes up, one goes down, that's inverse. They both move together, that's direct. Moses.
Never mind, kids.
The formula, if those variables are moving in the same direction, direct variation is right here. If they're moving in opposite directions, it's right here. Okay, so when I look at the next question, C, P varies directly as the square of Q. Now you are going to use this format. What was this one? Y varies directly as X. Now it's P varies directly as the square of Q. P varies directly as the square of Q. You see how it's the same equation but the variables are different? In this one, it's Y varies directly as X. In this one, it's P varies directly as Q squared. M varies inversely. M varies inversely as what? The sum of A and B. Y varies inversely as X. M varies inversely as the sum of A and B. Height varies directly as weight. Height varies directly as weight. Uh-oh. Y is proportional to X. The word proportional is direct variation. So when it says Y is proportional to X, this is your answer. So this is the answer to A and F. When it says two things are proportional, that means they vary directly. Except G doesn't say proportional, it says inversely. So G is going to follow this one. Rate is inversely proportional to distance. All right, let's try one over to the side. We've got some spare room over there. Try this one real quick, just make sure everybody's on board. We'll do two, just make sure you're on board. M varies directly as C cubed. And N varies inversely as the square root of B. See if you can write those down real quick, the formulas for those. M varies directly as C cubed. N varies inversely as the square root of B. Any volunteers for the first one? You got that one yet? Jordan? K.
C. Q.
What do you think, class? Is Jordan correct?
Yeah.
He absolutely is correct. Varies directly. Y varies directly as X. M, C cubed. Perfect, Jordan, thank you. Anybody got this one? Savannah, is your hand up?
Y equals.
Well, not Y.
Or M equals K over the square root of B.
What do you think, class? Is she correct?
Yep.
Y varies inversely as X. N square root of B. Okay? So now we're going to do a couple word problems. We're going to do these in 3 steps. The first step, I want you to read the first sentence, just the first sentence. Temperature is directly proportional to volume. Stop. Write the formula. Temperature is directly proportional to volume. What's that going to look like? Everybody okay with that? All right, first sentence, going to give me my formula. All right, let's look at the next sentence. If the temperature is 70, then the volume is 30. Now look at what I did. Does that make sense to you? It gave me a temperature and it gave me a volume. Now, what am I going to be able to figure out from that equation? I'm going to figure out that K is 70 over 30, or 7/3. So now my equation, this was sentence 1, this is all sentence 2. Now my equation is T equals 7/3 V. This was my beginning equation, but now it's a little more special because now I know what K is. Still with me? Now the third sentence. Find the temperature if the volume is 20. Well, what do you think I'm going to do? To find the temperature if the volume is 20. I'm going to plug in 20 for volume, right? So T equals 7/3 times 20, which is 7/3 times 20 over 1, which is 140 over 3. So your answer to the last question is 140 over 3. One sentence at a time. All right, do B. Write down what does the first sentence tell you. In the problem, what does the very first sentence tell you? Lindsay?
V equals K over V.
V equals K over P. Let's talk about that. Everybody good? Volume varies inversely as pressure. That's the setup. Okay, so now ready for part 2. What did it tell me? If the volume is 200, the pressure is 40. Which means K equals a big number, 8,000? So what's my equation? Now I know K is 8,000, so V equals 8,000 over P. You okay with that? And now the last step. Find the pressure if the volume is 950. There's your equation now. So the volume is 950. And we're going to find the pressure. Okay? How do we solve that? Let's move the P over here. And then divide. So you do have a little arithmetic to do. And these numbers are not, often they're not very nice. I got 8.42. All right. Everybody okay with that? All right, quick recap then. Quick recap. How do you know, if they don't say inverse or direct variation, how can you tell? What's the difference? In direct variation, what happens to your variables? They both go up or they both go down. They're moving in the same direction. Okay? Length of your foot, shoe size. Direct or inverse variation? Direct. The longer your foot, the bigger your shoe size, right? Direct variation. Okay, how about, the measurement of your waist and your pant size? Direct pants size, the size of your pants. Inverse or direct? Direct. The smaller your waist, the smaller your pants, right? How about, trying to think of an inverse. Can you think of an inverse? I've already used my two best examples. And what? Okay, that's a good one. He says the price of gas and the amount he can buy. In other words, how much is actually in his car. That's inverse because the cheaper the gas, the lower the price, the more you can afford to buy. That's a great example.
What about the more you drive, the less gas you have?
Okay, the more you drive, the farther you go, the less gas is in your tank. Good, that would be inverse variation. Yeah.
How fast you go after you hit terminal velocity?
All right, so anyway, we all have a general sense of what inverse and direct variation is, right? Okay, what we're going to do now then is I'm going to give you a practice quiz